Hi! Time to have some more fun with my new favorite toy, a permanent electromagnet. How little a weight can a magnet with a pull force of 190 kilograms be persuaded to drop? Do the two poles at the center and rim lose their magnetism at the exact same electrical input? And can I use the magnet to launch springs and payloads? Let's find out! Be careful near strong magnets. Don't let them bite your fingers. And protect your eyes when things whiz around at high speeds. After figuring out how to use this permanent electromagnet in a previous video, let's test it even further. Starting with how little weight I can make it drop. This magnet can hold up to 190 kilograms, so making it lift and drop 1¼ and 2½ kilogram weights is too easy. How about a pink paperclip instead? That will require a precision I would not expect from this strong a magnet. I will start at the setting determined earlier to give close to zero magnetism on the center of the magnet, even though the paperclip is not really touching the center here. Okay, no drop. As I reach out to fine-tune the setting, I realized I had forgotten to turn on the timer. This magnet has a duty cycle of max 30 seconds on, which is nothing when the fun makes time fly. Second try. Oh, that was odd. At the exact same setting, the magnet let go of the paperclip this time. So, despite a max holding force of 190 million milligrams, the magnet can still be fine-tuned to drop just 412 milligrams. Very impressive. Though you might argue I am cheating a bit by using a plastic-coated paperclip. Well, I chose it for its higher visibility on a small screen, but you're right. In the world of magnetics, even fractions of millimeters matter. Let's try with an even smaller uncoated paperclip. Aw, so close. I might have crossed the lower limit here. The paperclip itself will be magnetized into a weak magnet after sitting in the permanent electromagnet's strongest field. So even when the magnet isn't magnetic, the paperclip can still hang on with its own magnetism. Maybe this paperclip will drop if I find a setting where the electromagnet center pole switches just enough into having the same polarity as the touching pole of the paperclip. But in reality, no one will buy such a strong magnet to only move the weight of a paperclip. A more relevant result from this test is how both the center pole and rim pole seem to be fully demagnetized at the same electrical input. The pink paperclip bridged the two poles, yet still dropped at the same setting. Let me measure the pole's magnetism at 250 milliamps intervals and see if they truly reach 0 millitesla, no magnetism, at the same setting. I think this is the first time I dual-wield my magnetometers in a video. Oh, look at that! I am pleased to see such a linearity. Not only does it make the magnet highly and easily predictable, I can derive a formula from the two endpoints. It also confirms that my aging meters are still consistent. Great! From this single test run, it looks like the center reaches no magnetism a little before the rim, but they are very close. In practice, I would say this magnet can be assumed to be fully demagnetized at the full surface at the same electrical input. Before moving on, I will restore its magnetic strength simply by giving it a run at reverse polarity, momentarily doubling the power of the magnet. More about it in the earlier video. After a short message, I will prove that I will never get too old to play with magnets. A big thanks to all my patrons. I appreciate your help with keeping these videos like this one coming. For just $1 a month, you can help me out too and get full access to all my posts on patreon.com. Link in the description. Thank you. Alright, I have these two springs that many of my permanent magnets will hold fully compressed, but not release again quickly. I can't turn off a permanent magnet without destroying it. I can turn my electromagnet on and off, but it is too small and feeble to hold the springs compressed. I really need a larger electromagnet. Maybe the bigger permanent electromagnet will do it. Small spring first. Yep, holds fine on the center. How about the bigger, stronger spring? Whoa, this one is at the limit. Barely holding. Now, the question is, will the magnet let go of the spring slowly or quickly? That worked well. Nearly took out my overhead fluorescent light. Now the stronger spring. Did I mention this is currently my favorite toy? These launchers were with the power supply set to neutralize the permanent magnet. I wonder if the launch speed is variable with the power supply setting. How softly can the smaller spring be decompressed? Nice! Clearly launched with less acceleration at this lower setting. There is some room for varying the launch speed. Switching to the larger spring. I'd say there is way less room for varying the launch speed of the larger spring. The magnet, even at its full strength, can barely hold back the stronger spring. Next obvious step is to see how much of a payload the big spring will lift. Not a new satellite launcher for sure. Now, I am not a specialist in spring ballistics yet. But it takes roughly 320 grams to fully compress the smaller spring by 4.9 centimeters. And roughly 660 grams to fully compress the large spring by 7.2 centimeters. I need a better way of measuring force for full compression. Any suggestions? Anyway, if my measurements and calculations are right, the springs can deliver moderate work energy of 77 and 233 millijoules by decompressing. With a weight of 2.6 and 3.1 grams, I think they can theoretically fly up to 3 and 7.5 meters straight up, when ignoring air drag and any residual magnetism in the magnet and spring, trying to keep them together. The distance seems about right. Whoops, almost took down the Hubble telescope there. That max theoretical height quickly drops to 13 and 40 centimeters when adding a heavy 57 grams tennis ball. Again, not far from reality. Though this 10 times lighter, oversized ping pong ball is more fun to launch. Hope you enjoyed this video enough to click like and perhaps subscribe for more like it. And let me know in the comments what else you would like to see me test with this magnet. In any case, thanks for watching. Bye for now.